Hello, welcome to the Network Automation Notes podcast, where we explore the latest in network automation from a practitioner's perspective. I'm your host, Eric Cho, a network engineer who loves everything about network automation. Today, we'll be exploring an important but sometimes neglected aspect of networking, the optical networks. Joining us today is Michal Pecek, consultant and teacher in optical communication, whose work has transformed some of the world's biggest and most prominent organizations, including Google and Alcatel-Lucent, now known as Nokia. From pioneering flexible DWDM solutions to building the tools that automate complex design and provisioning tasks, Michal has been at the forefront of bridging the gap between optical hardware and intelligent software. In this episode, we'll dive into the world of optical networking, of course. Also, we'll talk about the challenges he has overcome and his vision for what the future holds for network infrastructure. So I can't wait to get into this conversation. Welcome to the show, Michal.
Hello. Thank you for inviting me. And
Yeah, I mean, it's great to have you on the show. First of all, did I pronounce your last name correct? Maybe you could just say, it doesn't matter how much I tried, right? It's always better to come from you. So please tell us.
yeah, so my name pronounced in Czech or Slovak language is Michal Pecek. Don't worry, it's really difficult to pronounce for most of the people I met. Even for native Czechs, sometimes it's difficult to pronounce.
Cool. At least I get a passing grade, I suppose. I get A for effort. Yeah. So just please tell us a little bit about yourself. Mihai, if I bump you on the street, and just say, hey, tell me about yourself. What do you do? Like that's what we customary do, at least in America. So tell us a little bit about yourself. What's your background? How did you get here?
So I started with the computers in really early age. My father was chief of the information center on university, so I had access to computers.
Wow, that's impressive.
Since 15, 16 years of age, behind Iron Curtain, that was a bit of a big win.
Right.
And start playing around, obviously first games, then started developing. I went to university, study software development. After 3 months, I dropped out and started working. It just was a little bit too slow pace for me, and I really wanted to go into the practical life. So I just started in a small company in my hometown, then moved to Alcatel, that time big telco company, started working on automation on old S12 machines. That's the voice switching system. And one day came an opportunity to move to Italy to test software for transport networks. And 22 years age, Italy from Slovakia, I just jumped on it. Yeah.
Where do I sign up, right?
Exactly. It took me about 20 seconds to decide. And that's how started my relationship with the optical networks. Start testing the software, then installation of the new management system at the customer sides. Because at the golden age of 2099, 2000, it was like no, always be too late, always installing the beta version of the software. So the guys who are testing it, they were also installing it and troubleshooting at the customer side.
Right.
And slowly progressed from maintenance to design small networks, then bigger networks. And after a couple of years doing solution architecture, it's called all technical pre-sales, Google decided to buy 100 gig transponders from Alcatel-Lucent. Alcatel in between merged with the Lucent, so it was Alcatel-Lucent. And they were looking for experts in Alcatel-Lucent technology and 100 gig transmission. And I was the lucky one to get the job at Google. And there I was doing like the normal stuff like optical designs, helping the installation commissioning team to fine-tune the network and like the typical optical network engineer stuff. But I realized how easy it is to develop a software at Google. Like at the traditional companies, you have to be part of the R&D team to do something like that. In Google, just look around, it's open source within the Google.
Right.
You just write something, get it approved by the reviewer, and off you go. So that's how it started. Started writing small tools to help myself or installation commissioning team. And then it grew slowly, step by step, into much bigger tools. And one of the kind of Christmas joke or just fun project where my manager told me, look, I spent all my holidays during the summer, so I had to stay alone in the office during the Christmas.
They're like, hey,
What if you just do a little bit of a planning tool, small MySQL database, little bit of the front end, nothing complicated,
right.
just to bridge the gap. And
small project by Google standard.
Yeah, no, we were thinking like maybe a month or two development, and we'll use it for 6 months, 1 year, and then we just use the proper planning software, which we were waiting for.
Yeah.
And out of that was 7 years long project, and it's still running even now.
Oh, wow.
Nothing is more permanent than temporary fix.
Yeah. But this project itself has to do with optical networking, I suppose.
Yeah, it's planning. It's not exactly with the hardware itself. It's more
Yeah.
like the planning of the network elements of the rack space and power planning, spectrum planning, all that stuff. Like vision of the network into the future, like 2 to 5 years.
Right. Got it. But back to what you were talking about, something that really kind of piqued my interest, and I do want to ask you about because you mentioned your dad, your father, give you access to like research network, and which is a privilege under circumstances and all that. But then you dropped out of your college study. That must be difficult, right? Coming from like a father's perspective, I have two teenagers now, and coming from like a Chinese family, that's almost unthinkable, right? I mean, it sounds sexy and romantic to drop out and pursue your passion, but in reality, that must have been difficult for you. Was that like a little family rebellious thing or?
A little bit. It wasn't difficult for me. I didn't really think about the consequences. Yeah, I was 18, 19 years old. It wasn't too difficult for my father. He was always like really easygoing. My mom was bit hurt. My mom was really preoccupied that I will never get the real job. She was always like in the maybe towards the end of my Alcatel-Lucent tenure when it was like, okay,
You'll be all right. Yeah, Mihal's gonna be okay. Yeah.
it looks like you got a decent job. Then I'm not sure she appreciates the Google job, that how special that was. And yeah, but she was really preoccupied that I ruined my life by not not waiting. It was a bit slow at that time. It was 90s in Slovakia. Really was difficult to find good teachers and somebody who knew software development and wasn't working in a private sphere and wasn't like making big bucks in private companies writing software, but teaching on not so well paid jobs on university. And it was just passing by a friend of a friend who just mentioned, yeah, these guys are looking for a software developer. I started, okay, part-time, young boy, earning first money from part-time was full-time, and then it went.
Yeah, I don't know if you have your kids or anything, but for me, at least in the last few years, the university enrollments has been going down, and people start to questioning, if the universities were at the up of time. So that's why, I was kind of curious on, your view set, especially coming from that background, that age of time,
Mm.
that how that decision came to be. But yeah, that aside, fast forward, you turn out okay, you're doing some crazy scale stuff. So tell us a little bit about optical networks, right? So for those of us who are not optical engineers, to me it was only in the later years of my career at cloud providers that we started to have dedicated optical engineers, right? Like not a service provider but cloud provider, that at certain scale it requires dedicated long haul planning or power equipment budgeting. And when they start to procure like long haul fiber from dark fibers, then they could start doing DWDM and all that. So tell us a little bit about, from your perspective, if you were to explain to a 5-year-old, which is kind of what my brain is, like, how would you explain to an intelligent 5-year-old what optical networking is and how does DWDM fit into that? Maybe we just tackle that first question. What is optical networking?
Optical networks, what we say, it's they are the networks where we play with the light and we transport the light between two endpoints, and those endpoints convert it again to electrical and then feed some client, what we call client devices. So typically in these days, IP routers, Ethernet switches, something around Ethernet, but it can be anything. It can be storage area networks. It's many other protocols. There used to be SDH or SONET in US, which all those slowly die off, and the predominant client protocol with transport of the optical networks is Ethernet these days.
Sure.
And in between, we somehow shape the light to transport the information, making sure that it's still readable on the other side.
Right. Well, maybe we should explain a little bit more, right? So the reason you can just throw Ethernet or throw a coax cable from over long distance because the signal loses its strength over time, and fiber is a little bit better than that. However, it still loses signal. So at which point you got to boost the signal, but you can't indiscriminately boost the signal because you boost the noise as well as the signal itself. So you, at some point, you got to clean it up, and then you amplify it, and then at some point, then you terminate at your client devices.
Yeah. So originally it was just one hop. People were so excited started about the optical. So we just swapped, a few kilometers of the copper cable with the optical fiber. It was much lighter. The transmission didn't need so much power and so on.
Right.
So there were like 50, 60 kilometers hops, especially the SDH network, where the 50 or 60 kilometers, you read the signal, convert it to electrical, maybe demultiplexed, add some virtual containers in SDH, so add some streams, drop some data streams, typically just voice at the beginning in 80s or 90s. And then you continue again and again and again. The problem is that in every 50 to 80 kilometers, you have to have quite complex device, which is big, and the whole signal is demultiplexed, stopped, and then recreated. So you have quite complex interfaces on both sides of the transmission. That's when the DWDM came in.
Okay. What does it stand for?
It's dense wavelength division multiplexing. So
And how do you explain that in English?
multiplexing is mixing slower signals into the one faster. Typical thing always is TDM, so time domain multiplexing, which was happening in the SDH on other signals, where you just merge them and a small chunk of each signal you mix on a time. So one split of a second you transmit from the source 1 and 2 and 3, and then you transmit the whole signal on the faster speed. With DWDM, it's dense wavelength multiplexing. So we transmit parallel signals with the different wavelengths.
Yep.
We mix them up into one light stream. And then after a couple of amplifications, we just demultiplexed it again. So if you're a fan of Pink Floyd, you might have seen on the LPs, the optical prism. That's exactly what happens. You have the light, which has multiple frequencies, what you see in a normal light, but that light we use in transmission is in non-visible spectrum. And running it through the prism, it separates all the wavelengths, and then you can read every single one of them separately.
Right. When I was learning about like the hybrid, fiber network, the way I saw it was people were telling me about the analogies through radio, right? Like, so in the same airspace, you could have different stations that transmitting at different wavelength. So as long as you tune into that wavelength, like, I don't know, Kiss FM 172, right? Like whatever that wavelength was, that you tune into that and you can listen to that. And then you tune into a different station, a different wavelength that you could tune into that AM, FM, whatever. So same thing in fiber, except this would be like what, 15, 10. At one point I have like that whole list on different wavelengths.
There are quite a few windows as we are moving through a multi-mode to single-mode fiber. I don't want to dive into this because
Right.
there will be just another session completely on the development of that. But you just mix the signals, then you amplify them after those 70 or 80 kilometers when it gets really weak.
Yeah.
And you use a simple amplifier instead of having a complex device which demultiplex everything, converts everything to electrical and then back to optical. You have simple cheap amplifier which boosts the signal, and you go another 80 kilometers and so on. With advancement of the technology, we now can go not 2, 3, 400 kilometers, but we go 2, 3, 5,000 kilometers. We have trans-Pacific, transatlantic submarine cables. So we can go really, really long distances before we have to convert that light again to all electrical signal, reshape it, retime it, get a really nice clean signal again, and then maybe retransmit it again if you have to go yet another 2 or 3,000 kilometers, or feed it into the client device.
Wow, that sounds amazing, right? Because if it's like underground, I imagine it's not a small task to be able to having to re-amplify or doing all these complex operations so often.
The biggest challenge is because it's analog system.
Right.
We live in digital world. All the network engineers are thinking about binary codes and it's all digital.
Yeah, especially network engineers. Yeah.
Yeah. And this beast, it's really analog. So you fine tune the amplification, you play with the gain of the amplifier. It tilts left or right in the spectrum depending on how good the amplifier is. Nothing is like exact. This is a good value. Like the amplifier gain, is 20 dB a good gain or not? It really depends. Like the typical answer always is, it depends.
Shout out to my friend Ken Salenza, but yeah, it depends. That's his handle, right?
Yeah, it's really something completely different because everything is somehow okay until it's not okay. So
Right.
we will probably talk about the automation challenges and stuff like that. This is one of them, that you have to look at it from the analog perspective and see, like, every time you change something on one side of the network, it has effect on the completely other side.
It's like the butterfly effect, but like more immediate, probably.
Yeah, so or even in the future, that If we have time, I will tell a couple of stories about how the things can break in really strange ways.
Mm-hmm.
And yeah, going back to the networks, what we talked so far is just one point-to-point link. And that's how it was in the 90s, early 2000s. And then we start thinking, okay, but in the middle, I want to drop just one wavelength out of those 16, 32 at a time. Now we have 100, 200 wavelengths in one fiber.
Mm-hmm.
And the start was like fixed OADM, where you had a special device, the Prism, which selected one or two of those wavelengths, dropped them on the local side so you can connect it to the router in the middle, and everything else is going optically through.
Right.
So it's still really, really cheap. For those pass through, pretty much nothing changes, but you can drop something in the middle. But it's all physical. So if you want to reconfigure, if you want to change it, you have to jump in a car, drive to that side, and then start filling with the fibers or swapping the physical components, maybe shutting down the whole node and whole end-to-end transmit.
Right.
And this is how, if people understand or if people know something about optical networks, this is typically where it stops.
Mm-hmm.
It's fixed, it's point to point, you can't change it.
Yeah, you roll a truck, it's fixed. Yeah, that's it.
Yeah, that's why the automation of the optical networks, I think, is a little bit lagging because
Right.
of this myth that it's fixed. Over times, we now have RODMs, or remotely operated airdrop multiplexers. And that means that you have a box where you have that prism and you have simplified hundreds of small mirrors moving left, right, up, down, and shifting that beam of light, that one wavelength, into a different ports. So via the software, now you can say these 80 wavelengths coming from east, I want 20 of them go north, 20 go west, and the rest I want to drop here.
Wow.
And a minute later, you can completely change it.
Oh, wow.
And now you can create a mesh networks, not only point to point or simple rings. You can create a really mesh network where you have central RODMs, which have 5, 6, 10, or even 20 degrees.
Right.
A degree is a way out of that node. And that node can switch the wavelengths and the optical channels any way you want.
Right.
And that's available for almost a decade now on the hardware level.
Oh, really? I am so behind on this. And I was just thinking how amazing it was, right? Because that means even as an island, I mean, all of my families are in Taiwan. Most of the connectivity through Taiwan is through undersea fiber. And typically they go through either through, like the Taiwan Strait, where they have like these, geopolitical tensions, or they go through the Pacific Ocean, where it's like shared between, Australia or Japan, and then you kind of just tune off, right? So it makes bursty really, really undesirable because you have these fixed, like you said, prisms or mirrors that you have fixed bandwidth dedicated to it. But in your case, if this is dynamic, then I could kind of dynamically shift so that when there's downtime in Australia, I do it a little bit less. But if it's like peak time or whatever, that makes it really dynamic, which sounds amazing.
Yeah, but it is amazing only on the hardware level. We have the software, and I wrote a couple of tools at the beginning
Okay.
of my stay in Google to do this, like really, because for some reason, I don't know, I never made the research, but for some reason, management software for optical networks, even the PDH, SDH in the past, now DWDM, are really GUI based.
Oh, okay.
These people are really, I'm not sure I can say obsessed with the GUI. Like everything has to be a GUI, and there's lots and lots of clicking.
Yeah.
And when you turning up 100 gig wavelength a week, okay, you do a couple of clicks, it's fine.
Right.
But then when you go to the hyperscalers, and these guys are turning up like full line system with 100 wavelengths on day one,
Mm-hmm.
it's lots of work and repetitive work which can be automated.
Yeah, I mean, that is just another point about hyperscalers, right? Like at scale, everything breaks, and at scale, everything becomes a challenge. Even if you could do something manually for the first few, it just become unsustainable, right? Because you cannot scale linearly. So what you mentioned about these, provisioning or management system being GUI based, is that like one of the first challenges? I mean, I would imagine if somebody like Google or, like the service provider that could put their money behind it and say, hey, we're not going to buy this unless it has some sort of API or some sort of, remote management capabilities. Is that what happened? Or was that just something that you guys have to work with until something changed?
It was a bit of a mix of both. There always has been, not always, but eventually there were like command line interfaces. There is a configuration protocol called TL1. It's quite old and clunky, but it works. So there are ways how to do it by the scripting or some automation software. There are a bit of a challenges with it. You have to keep the full state on the management system. Those network elements on amplifiers, they keep only their own state. They don't know anything about left and right nodes. And that's all fine. The biggest problem is this is solvable.
Okay.
The problem is that people still in their mind, at least that's my view, keep that notion that transport is static.
Okay.
Then all the processes around that are based on that one with that assumption, and they kind of transported information about the topology, about the changes on transport network via emails, presentations, meetings, and stuff like that, which you cannot automate. You cannot go around it. No, we could do something what's called optical channel restoration. So imagine you have a fiber cut on one line.
Right.
And those 80 channels go down and you're losing 10, 20, 30 terabits of capacity.
Right.
It's a huge blow to your network. And now you have to wait a day or two or a week to repair it. Depends what kind of fault it is, but typically at least a day or two. And with this flexible ROIDMs and with the flexible topology, you could create a different channels going around that failure. If you have mesh network, have different routes, if they short enough, you can create a different channels because you reuse those transponders, which are now useless because of the failure, and you connect them different way. But that topology now is different to what you had a few minutes ago. And that brings a couple of side effects. One typical example, what I'm using is you have a risk analysis meeting and you say one day, a week before this failure, you say, yeah, I want to shut down this link because I'm doing some maintenance on the fiber or hardware or whatever.
Right. Shift the traffic. Yeah.
And let's say we don't shift it, but you say, okay, I will shut down this link. It's carrying 1 terabit of capacity. My network can live with it. We did the analysis. Everything is fine, guys. Today is Monday, Saturday, midnight. You have a go.
Right.
On Saturday, 10 p.m., there is a fiber cut somewhere else on the network. You do the reroutes and you push on that link, which was carrying only 1 terabit. Now you put 40 terabits of the capacity temporarily for a couple of hours or a day until you fix that problem. Now, definitely those guys shouldn't shut down that link, but they have that go email from a week ago. They can do it and they have no tools, nothing to stop them. Say, look, that information you have is stale, it's old.
Right.
And you have to stop. You cannot now shut down the system because you're shutting down not 1 terabit, but 40.
Right.
And this kind of like operational tools and interconnection of the other tools, not really transport related, but all the planning, all the operation stuff, that needs to move from that human communication by the emails or documents, whatever, to API based or signaling when the network says, oh, situation changed. The current topology, this very second, is this. And you don't have a go anymore for this outage.
Yeah, so I'm actually hearing 3 different challenges in that just short passage, right? I heard 3, right? Like, where's Waldo? And you guys might have heard 10, but the 3 big ones is, first of all, technical challenge, which, you talk about GUI but it's solvable, right? Like, given time, given intelligent people, enough eyeballs and budgets on the problem, it's solvable. But the second challenge that I heard was, kind of organizational, mentality, because like you said, it's always been static, it's always been top secret, and the topology has been handled through traditional methods, emails and graphs and so on.
Yeah.
And it's been kept in the vault. So that's the organizational kind of inertia, right? Like people have their fixed way of thinking. And then the third one was because of that, the derivative of that second challenge that arrives in the third one, which is the most important and most visible that gets you on the front page, is this monitoring system that's kind of outdated because of the inaccessibility of that information. So like even the first challenge I thought would take in years to resolve. And how do you begin to think about the second and the third, right? Like how do you change people's mind to begin with and say, hey, hold on, guys, this is dynamic now. And was it just like take one, headline on Wire News to like, hey, let's put some budget into this?
The first technical problem is not so big. It is solvable. In fact, many companies solved it already. I did it back in 2014 when I started writing. One of the projects I was working on Google was this automated provisioning. So really taking a definition of the channel from the planning tool and push the configuration into the network and then changed it. Google has kind of a unique challenge that they're having lots of pops and then growing really, really quickly. So it's quite common that you move from a pop to a bigger one because you cannot grow that one because everybody around that cage is already taken. So you have to move to different building and so on. So quite often it's like migration of the whole line system. And that means 80 or 90 channels shut down and recreate within 1 hour during a night. That was the first challenge that and at that time it was 100 gig wavelengths, but 10 gig clients. So you have 800 10 gig connections you have to shut down and recreate with clicking. We just tried and said, okay, no,
That's a pretty expensive click.
that doesn't work at all.
Yeah.
So that was the first case for that script, was this kind of migrations from a pop to pop, and obviously the big capacity turn-ups when you
Yeah.
on one day you want to turn up 20 wavelengths. Again, you don't want to spend 3 hours clicking.
Right.
And the same tool that you use also for the rerouting is pretty much the same thing. You just decommission one optical channel and you create a different one. You need some intelligence and engine to figure out which way is okay or estimate the performance. What we didn't say is that for end-to-end transmission, you have simulation tools. So when you're planning the network, it will tell you, yes, you will arrive at the endpoint with a 200 gig signal with some margin. Like 1 or 2 dBs margin. So you have something as a spare performance for fiber cuts, aging of the components or whatever. But you cannot do 300 gig because that's too much. The modulation is too complex and you won't be able to read it at the end.
Right.
And now when you start rerouting dynamically, you need something which can calculate it or pre-calculate it really quickly and tell you, yes, you can go this way, but you cannot go that way because that one is too long. So that's the technical challenge. But that's all doable, and actually I have seen it working in different networks. That's fine. If you really want to, you can find the software to do it. You can write your own software. There are some examples of that actually working.
Right.
That organizational stuff, that's, in my opinion, much tougher nuts to crack.
We like dealing with technology. We don't like dealing with people, man. They're tough. They're unpredictable.
Yeah, so when I'm discussing this, I tell people, you know what? Make a note every single time you use a chat or an email or a meeting to transmit some information about the topology.
Right.
And make a note in a document somewhere and just keep notes of all these instances, and all those have to disappear. I must be able to, as an IP layer 3 IP designer, I must be able to figure out what exactly the topology is this very second via API call, not picking up the phone or writing an email. And once that's achieved, then you can think about, okay, now we can really tap the potential. And the potential is huge. These reroutes, they take seconds, maybe half a minute or a minute, depends on the situation. So they don't compete in any way or shape or form with the layer 3 rerouting. Forget about milliseconds.
Yeah. Like OSPF convergence. Forget about that. Yeah, I mean, not to mention BGP, right? Yeah.
Yeah. But what you do, you're drastically decreasing MTTR, mean time to repair.
Right.
Because now instead of 2 days, you go in 2 seconds, a minute or two, or something like that. So that's significant. And we will see when. So far, I have a feeling that people solve the problems with capacity. Like you can solve anything in networking with the more capacity.
Yeah. Just throw more money and more bandwidth at it. Yeah.
Yeah, and it will work. Not sure it's going to work. That's other problem we didn't touch yet. It's that we're really slowing down. It looks amazing when you look at the speeds of the channels. We started with 2.5 gig in like late 90s, 2000. Then we moved to 10 gig per channel. Then we moved to 100 gig per channel by 2010, 11. And now we are on 800 gig, 1.2 terabit, also 1.6 recently. But these new channels are wider and wider spectrally. So instead of transmitting 5 100 gig channels, now you're transmitting 1.6 terabit, but only one. You don't go 16 times the capacity. If you look at the capacity of the fiber, you're going only 3.1 time or something like that.
So we're hitting up against the kind of the physics limit, right? Like what you're saying is there's only so much we could cram into a pair of fiber bandwidth wise, not to mention the quality of fiber differs greatly globally, right? Like, so I imagine this is just putting more and more stress on the quality of your fiber. Even on the perfect pair of fiber, we're hitting up on the ceiling of that.
On the core networks, definitely. Like if you look at the metro networks or access fiber to the home and stuff like that, we have plenty of capacity there. But those ads, if you look at the YouTube from like 80s, like the optical fiber, unlimited capacity, will last forever.
Yeah, yeah, yeah. That's what they say about IP address too, by the way.
Yeah, something like this. So we already have big hyperscalers deploying 2, 3, 4 parallel line systems between the data centers. So, but this is linear scaling. It's not going exponentially up, and it's going to be interesting to watch like what's going to happen.
Let me move back a little bit because I do want to double click on what you said about the organizational challenge, right? So I think what I'm wondering is yes, now you solve the technical problem, maybe with scripting and maybe we're tapping into the planning tools. And now that you have a workable solution, but people still have that mindset. So one thing that you talked about was to calculate the ROI. Like how many times did you, I don't want to say waste time, but how much time did you spend on doing the chats, the
Yeah.
emails, all the other stuff and calculate, I don't know, your salary and
Hmm.
the time that you spend, away from your family and what is it worth to you. So you calculate the ROI. Was there any other, aspect that you could recommend people if they face the same challenge as you? And if you look back on the challenge that you face on trying to convince people making organizational change, what would you recommend people take besides calculating your ROI?
I think it's really this view on the network that we cannot throw capacity at the problem anymore, at least in the hyperscaler. So we have to look at the ways how to use the spectrum more efficiently.
I see.
And one of the ways is to increase the availability time or decrease the downtime.
Hmm.
That way you can live with the smaller capacity. But eventually we will have to come up with a new technology. There are exciting ways with the hollow core fiber. So you don't have the silica based fiber, but you have vacuum or air in the core. And there are many other approaches how to increase the capacity. But from the operational point of view, I think it's only the physical limits will push people to do something significantly more complicated. Like having physical topology static, as it was for last 2 or 3 decades. It's simple, it works. Why change something which works?
Right.
Unless it doesn't work anymore.
Okay. I see what you're saying. So let me rephrase that and see if I got you correctly. All right. So yeah, you calculate ROI, but it's still, people are still trying to throw money at the problem and they could still solve things with capacity. But here you dealt with a hand of reality, right? I just say, hey guys, if you squint really hard, you can actually see that we're hitting up the upper bound. And if we don't prepare now, in the future, it's gonna bite us and you're not gonna meet that, KPI that you have and you're not gonna get your bonus, man. So
That always works.
that's super smart, right? Like you try to evaluate your situation and see what kind of message would stick. In this case, it was the reality. It was the physical upper bound that you're gonna hit. So why don't we just fight it now instead of it bites us in the butt?
Yeah, and you have to remember that these kind of innovations come really, really slow. To move to like we're using a really narrow band in the whole spectrum you can transport through the fiber, but it's the best. This is the best band, lowest attenuation, best performance we can find in the whole spectrum. We can use different bands. We could move to now we used to have only C band. Now we have C plus L band, and we could move to a different ones. But the different ones will need new amplifiers, completely new design, and that means new test equipment, new interfaces like the transceivers from which convert the electrical signal into the optical, new WSS cards, everything new, and that's going to take quite a lot of time, and then even more time to get the economy of scale.
Right.
You want something which is comparable in price to the current ones. So I think for a time being, we will be just stacking up more and more line system together.
Yeah.
And having more dense equipment which will deal with the 5-line system on one chassis, which now is handling only one line system, and like physical improvements in making the components more dense and less power hungry and more performant. But that's only linear, and it's saying only.
Yeah. I mean, speaking on somebody who truly has operational experience, right, Miha? I mean, for somebody who's just doing these theoretical, like at a university research or whatnot, right? They just, oh, let's just there's like C plus bands and all these new bands.
Yeah.
Let's just go throw money at it. But even if you just want to throw money at it, you still have to have, all these testing done, all the truck rows to, dig things up, to replace them. And all of these would take time. So even then, it's probably not going to solve your problem. Even if there's a technological breakthrough, that is not going to be operational until a few years later. And not to mention it's expensive operationalize. So yeah, so I mean that sounds good. I mean, so assuming that you have those solved, and people are saying, okay, Michal, let's do this automation thing, and how do you actually build the trust that to say instead of other people's, I don't know, a vendor's software or whatnot, like every vendor wants to sell their automation solution. How do you build trust for people to say use something that's open source or homegrown or anything like that, other than go buy a commercial software?
Yeah, that's very good question. It's good testing. That's the first one. What I found works really, really well. It's a mix of network engineers and software developers.
Okay.
If you think that you can write a perfect feature request document or whatever you call it, that document describing what you want.
You lost me at perfect because nothing is perfect, but yeah, go ahead.
Yeah, and then you throw it over the fence to the software development team who has never seen optical network. That's not going to end up well.
Mm.
So a really tight cooperation between those two teams, and maybe sometimes grabbing the software developer, put him in your seat and say, look, you're going to design the network now. You're going to deploy an optical channel now, so you know what it is. And you see our work, and you can now put a mental picture in your head, what you're actually building, not just some design document.
Spec sheet or yeah, exactly.
Yeah, or whatever. And sometimes I'm saying, like, imagine that somebody who have never seen a car, never drove a car, doesn't have a driving license, and somebody tells him to develop a self-driving car. Would you sit in that car? Would you test drive it? I would have some doubts.
No, yeah, I don't want to sit in that car either.
So that's the same thing with the software development. It should be done by somebody who tried it at least a couple of times. And on top of that, obviously, some good testing. But really, you have two choices. You wait for a vendor to hand deliver the software, and you might have 6 months, 12 months discussions with them to fine tune that software to your liking or to your case.
Yeah.
And then you have the comfortable chair and comfortable life saying, okay, they delivered, they're responsible for it.
You could point your finger at them.
If something goes wrong, yeah. And if something goes wrong, you just pick up the phone and call the vendor. Or you take the responsibility, you start writing your own software, which gives you great agility, great possibilities to automate everything you want, any way you want. But it brings a responsibility. It's your doing now. And yeah, if something goes wrong, you have nobody else to blame, just yourself, your own team. So
yeah, it does have to do with culture a little bit too, right? Like, is your company's culture that encourages accountability and encourages innovation, but you own it, like you said, right? Like, there's no fingers to point, but to look into the mirror. And that is a huge difference between maybe some of the enterprise networks that I've seen. It's, they don't have the manpower, they don't have the resources, human capital to make that happen. So open source to me is a great way to contribute, right? You have the collective intelligence and to do that. So let me switch face a little bit, because I know you just recently came back from AutoCon 3 in Prague, and you had was it a workshop or a talk on automating your optical network?
it was just the chat over the lunch, so bird of feathers, yeah. So
Oh, okay. So it's like a bird of feather. Okay, got it. Cool. So tell me a little bit about that, because that was the first time I've heard. So yeah, before we had the conversation, I really saw, because I sat on the board. So I did see that proposal, and that was very interesting to me even before we had the conversation. So tell me about that. What was your experience, and were people receptive, or were they still like me, like this old head that still had this fixed idea of the transport, the tunable wavelength that's just not tunable?
yeah, so a couple of people were just sitting and observing, like,
They were there for the free lunch.
yeah, free lunch, obviously, but thinking, oh, like, what the is this optical network about?
Yeah, they walk into the wrong room.
Yeah, like, yeah, would you like to, do you have any problem, or would you like to discuss something? No, we just came to listen and figure out what is actually happening in optical network, how you can automate it, and what it actually is optical network.
Right.
And there was like a couple of guys who really like dived head into the automation, and we started discussing problems like the spectrum fragmentation, like the modeling of the network.
Right.
And you could see like there were like two guys that they really just head down, no thinking, no planning. Just we're going to do something. And it's a brilliant way to start prototyping and figuring out what's wrong, how to do the stuff. And that was really nice discussion where we just told them, look, guys, if you do this, you're going to run into the trouble. And the reason why I know is you're going to hit the trouble is because I made a mistake 5-6 years ago. And it was quite interesting, lively discussion, lots of different opinions and different questions about how do we do this or how to especially model. It's one of the challenges of the optical networks is that they tend to stay in the network, in the ground for a long time.
Yeah, it's expensive. Yeah.
It's expensive. And also the process of installation, commissioning is quite long and tedious. And you can upgrade, like once you have the line system in the ground installed, you can keep adding new channels with higher speeds relatively easily. But that means that you might have equipment which is 10 years old.
Right.
Then you have a next generation which is 5-6 years old, and then you have brand new stuff, and they all behave differently. They have different communication protocols. They're like generations apart. And to make that work in somehow cohesive way, when you can deploy the channels actually across this crazy network where you have one span of one vendor, then you have to regenerate or you don't have to make all these decisions. It's quite challenging. Lots of theoretical people and all the professors, I don't want to tag them or disparage them in any way, but it's nice to see this presentation. Oh, this is the beautiful network and we're going to do like all this crazy stuff.
Like it's greenfield, right? Like this is reality here, man.
Yeah, that's the thing. There is no greenfield network in the world. And, one of the challenges was like we tried to decommission one line system for 5 or 6 years in a row. And every time we build a capacity to move extra so we can take down that system.
Yeah.
Somebody came, oh, we actually need it. So you have to wait one more year.
Right.
And then it's like that equipment is dying. We don't have spares. And actually, that was the final trigger. Like, sorry, guys, we have to stop. We don't have spares anymore.
Right.
Until that point, we kept just, postponing and stuff. And then you have completely different network element or section of the network which behaves in different way, communicates in different way. And that's then quite a challenge to make it work. And that was one of the points we discussed on the Birds of Feather and was quite interesting to see how the guys.
That's amazing that you guys have this conversation, right? Because I think it's a conversation that's worth having. However, I don't think as illustrated by AC3, right? There's no critical mass on the people who's facing those problems just yet. So therefore, it's an important conversation, but where can we have it? In AC3 would have been, and AC4 and so on and so forth, would have been a great place to have. And I'm so glad you guys had that space. And, congratulations to you for taking the lead and the charge for doing that. I do want to ask, like you said, all these challenges, they all seem very complex, very difficult to come across. What's your recommendation, if you will? What would be the first step if somebody said, okay, Michal, hey man, I hear you. When I grow up, I want to be like you. And what's the first step I could take? Is there any open source project I could contribute to? Is it just to join some sort of Slack channel or to just get in touch with you?
Definitely, like text me or ping me on LinkedIn or anywhere. That's one option. For the network engineers, not the software developers, for the network engineers who understand their problem, I would say just make a list of the most annoying tasks you have to do, and then pick the smallest one, the first. Really do it step by step. Like it might be tempting to say, okay, I want to now completely automate the network design.
Yeah.
That's not a good way to start. Find something really simple, stupid. Example from my past. When you deploy the network, you have like a design document where it's all the settings for every single link. You then deploy it, you ask commissioning engineers to configure the network that way. But sometimes they make a mistake. Sometimes they just too smart and want to clear the alarms just to make everything green. That's, just tweak it a little bit outside of the design. And that's the problem with the analog nature of the DWDM. It will look green, but it will not work as it was designed. And just writing a simple script which collects all the settings from the whole new link and compares it to the design file and flags the differences. So there's like two challenges. One, go through every single network element and grab everything you can from the network element.
Yeah.
Then categorize it, then look at the design file, look at all the settings you should set on the network, make match between the values and flag the differences. That's something relatively simple. At the time, I had to write it myself. Now there are tools from the vendors. You can just use the existing tool. But if you have some older network or smaller vendor who doesn't support this functionality, this is something relatively simple and very, very useful, because that can give you an early flag into a network, an amplifier slowly dying. That's again, going back to the analog. Amplifier will work. 1 week will drop the output power by half a dB. It's still well within the range. Everything is fine. The week after, it drops another half a dB. And then week after, another half a dB. And it still works. Everything is green. But if you monitor the network, if you do it automatically and you see the trend, it's still only little drops, like 0.1, 0.2 dB per week. You see the trend, you can hit the button and say, look, guys, this amplifier is going to die in 2-3 months. And I bet a bottle of whiskey on that. And it will happen. With that, you can get a bit of attention from the management. I did something like that back in 2002 or 3, and that was quite fun to play a Nostradamus when just placing bets on the network. And after we hit the third one, we got noticed by the management. So, okay, that project might have a...
Yeah. So how do you say "I told you so" without saying "I told you so"? You're like, hey, it would have been nice if we had, listened to me, a few months ago, and we would have saved you this outage right here.
But yeah, we were also happy that you need to confirm the theory. So it was nice to say, okay, these, and these amplifiers are kind of suspicious. And if they really die a few months later, then we can start jumping into a car. It's still an expense, still shut down the network, but it's on your own terms during the through of Saturday night or something like that, instead of
Right.
random time and random.
Exactly. It's a controlled exercise as opposed to something unexpected. Yeah, I like that very much. What I liked the most about that example was even something you thought was not automatable, or even you thought like, going in between the analog and the digital world, that there's still something that you could do, that as long as you start, right, that you start making a list and then you start picking down on the lower hanging fruits, and such as your monitoring example. So I do want to ask you about this transition between, because we should mention now that you're not with Google anymore and you're a self-employed consultant, and that's how you went as at AC3, and that I imagine give you a lot more freedom to talk about stuff and to kind of let imagination run free. So what is the kind of a difference for those of us who fantasizing going out of the enterprise world between working for a big fan company versus being a self-employed consultant?
Yeah, I really wanted to be in charge of my time. That was the motivation. And that's quite an illusion.
You still have customers. They just now, instead of Google, is like 10 different customers.
Exactly. So I think I'm even less in charge of my own time. I have weeks or months when I do relatively almost nothing, we could say. And then I have really crazy months. So that is something you have to be prepared to do. There is no regularity anymore, and including salary. Like you might have a good month, you have a bad month. There is no guarantee you will have any work at all in 6 months. So
Right.
it's something different. But before Google, I was involved in like the solution architect. Every month you have different project, different RFQ, completely different problem. And that was really energizing for me and was really fun. Then moving to one network was huge, and just to understand how that thing works and how it works on completely different scale.
Right.
Even working for like big telcos and working on, I thought at the time, big networks. Then I walked into the first meeting and I saw the map of the network and I said, I had to close my mouth.
Your jaw dropped. Yeah.
Absolutely. So that was a big challenge. But then after years, it becomes a little bit repetitive. It's still the same network, still very similar problems. And
Mm-hmm.
it kind of became a little bit of a routine.
Mm-hmm.
And I was looking for a change. So I thought this was a good idea. Depends. Yeah, it's definitely much more challenging from the point of view that I love to solve technical problems.
Mm-hmm.
And now I'm not only solving technical problems, I'm accountant a little bit. I am marketing manager. I'm PR. I'm doing all sorts of different things
Right.
outside of designing network, writing software, or talking to people about the technical problems. So I swapped one thing for other. We'll see what the future brings, but so far I'm really enjoying this.
Yeah, I'm glad you're, being honest and transparent about it, right? Because, like what you said, you initially, have a bunch of different problems, and you swapped to Google, which was challenging for a while, but it became kind of routine. Like you said, you went through the cycle, and it's kind of the same. And now that you're challenge yourself with just multifaceted, right? Like instead of just technical, you're marketing, you're your own sales, you're your own promoter, like coming out to network automation. Oh, we thank you for that. And so it's definitely different skill sets, but I would imagine this goes back to what you were doing previously, that you're encountering different challenges. It just may not be technical challenges. It seems like a good challenge to have, but definitely something to be aware of if you're thinking about going out of the enterprise world into your own consultant. So we have to ask this because this is 2025. So I have to ask about AI. It's by the contract. If you see the before you sign the dotted line, what role do you see AI play in the future of optical networks, if any? Right? You could feel free to say no. Right? This is BS, and it's never gonna do anything about it. But yeah, feel free.
I have a bit of a problem with AI.
Tell me.
I love AI fixing my English. I love AI creating crazy pictures. I'm using it in my LinkedIn now. I really became like a little bit addicted to having fun with AI.
Okay, like the mid journey addict now.
Yeah. The problem is that it's not reliable enough
Okay.
so far.
Yeah.
And if you want AI to help you out, you're drowning in a problem, you're drowning in a heaps of data and you don't know what to do with it, then AI can really help you out
Okay.
if you don't expect perfect result from it. So you're trying to figure out some patterns or relations. For example, with that monitoring, you have heaps of data points. You're measuring everything, or temperature on the amplifiers, or power consumption, input, output power. You have millions of data points.
Yeah.
And you have that primitive way that, okay, if the amplifier starts dropping output power slowly, it will die in 2 months. But there are many, many other correlations, many other ways how you can predict future with the help of AI.
Mm.
And that's, I think, really valuable.
Mm-hmm.
But what I'm scared of, and I see people using AI in authoritative way,
Mm.
asking the questions, like if you ask anything a little bit more technical about DWDM,
Mm-hmm.
you will get an answer which looks like, okay, this is truth. I'm telling you, this is one truth. If you Google something, you will get a million answers. And you have to do the research and come to a conclusion to some answer. This way, you get one answer which looks perfect.
Right.
And if you are not an optical engineer, you start reading it and you know a little bit and say, okay, these first 5, 6 lines look really, really good.
Mm-hmm.
And then on line 10 to 11 or 12, somewhere down, it tells complete BS.
Mm-hmm. Mm-hmm.
And you have no way how to check that. So unless you have really good unit test on the answers, then don't use AI in that authoritative way that you say, okay, whatever AI says, it's true, because it's not. It's just making up stuff. And it's pretty good in hitting the good answer. As I said, if you drowning somewhere around 10% success rate in analyzing your data and you want to bump it up to 60, 70, 80%, AI is perfect.
Mm-hmm.
If you need 100% perfect solution for your problem, stay away from AI or have a perfect tests. Or if I ask AI to generate a picture for me, I know whether the picture is good or not.
Mm-hmm.
I'm the judge and I say, yes, this is a correct result. I like it.
Right.
if I ask AI design a network for me, how do I know that this network will work?
Yeah.
How do I know it's going to have availability of 5 nines or whatever my KPI is? Or
Yeah.
how do I know it is actually doing the stuff? If you don't have a perfect test to make sure that the result is correct, then it's, in my opinion, really dangerous. And we will see, I think, lots of it's euphoria phase now. Like everybody's talking about it. Everybody has to have AI in the business description because it increases the share price.
Hey, you'll get more hits in your marketing, your search engine ranking if you just include some AI in there, man.
So we back to 2000.com bubble again, I think a little bit.
Yeah.
70-80% of the companies will go bankrupt, and we will have 2, 3, 10, 20, I don't know how many, small percentage of big winners, which will have really useful, nice tools, which will push the humanity, or at least optical networking, towards a better future. But what is going to be the killer application? Don't know.
You and I both, right? Like we don't really know. And I like that answer because if I think back on the AI ascent from Sequoia, 2025, Sam Altman actually did say this in passing, right? He only talked about, maybe like 20, 25 minutes.
Yeah.
And somebody asked the question and about like, what do you see the difference in age group on using AI? And what he mentioned was, people in our generation, because we have came from a background of we know a day when internet wasn't there. We saw the up and down for
Yeah.
cloud, social, and obviously internet itself. But so people in our age group, we actually use it as a assistant. We don't trust it completely,
Yeah.
but we use it as assistant, like a search engine. But people in the younger days, maybe 25, and nothing wrong with age, right? But what I'm saying, I'm rephrasing. Don't send me hate mails.
Yeah.
That they're saying people underneath a certain age, they're actually using as an operating system. So they actually upload a bunch of documents, and then they don't make major decisions without asking AI first. And that, to me, back to what you were talking about, is putting AI in an authoritative position to make important decisions without checks and balances, right? So then, like that unit test, that perfect unit test you talked about, how do you know it's making all the right decisions for you? It may be just looking great in the first four sentences, and then it tells you something that's completely off and you have no way of checking it. So yeah, I like that. And maybe just a generational thing that we use it as more of a consulting role versus a parent role, if you will.
Yeah. I think that the biggest problem is like when you see it now on top of the Google, or even if you ask ChatGPT or whoever,
Yeah, it's Gemini now. Yeah.
it gives you that one answer.
Mm,
And it looks like, okay, this is truth.
right.
If you don't keep reminding yourself, okay, this is just synthetic thing, it just grabs all the words around the problem and probabilistically just puts them one after another, thinking, okay, this looks like a good answer.
Yeah.
And don't go and check on it. It can be dangerous. And I think quite a few people will get burned by.
Yeah.
LinkedIn is now full. I sometimes was tempted to answer or correct people on LinkedIn about when they talk about DWDM. Yeah, you see lots of people just trying to get engagement and recognition a little bit. And you see copy pasted something which looks really like AI result.
Yeah.
And then start reading and okay, yes, this maybe, oh no, absolutely not, this is maybe. And it's surprising to me seeing 200-300 likes, great job, and I don't know, and I'm thinking, do these people actually read it, or is yet another chatbot just liking like two chatbots, one is writing and one is liking its posts? If people learn from that kind of source, they will make a mistake then eventually. Maybe it's just little embarrassment somewhere or something really innocent, but it might be a major mistakes. And I had the couple of cases where people were coming with completely wrong view on what the optical networks can do, and it took me weeks to convince them, you have this wrong, this is not going to work.
Yeah.
And this was pre-AI. The one thing which jumped in my head is like 12 years old, which was like big, long discussions about assumption. I don't know if you want to dive into the details. You have these marketing terms saying a channel can do 3,000 kilometers.
Okay.
And that's perfect fiber, perfect amplification. Like you really stretch it and you make it repair.
Yeah. In the perfect, everything else is perfect, right?
And let's say it is 3,000.
Yeah.
Now, every time you put a little bit more complex device on that path,
Yeah. Of
you destroying the signal a little bit more,
course.
like the ROIDM. So that one ROIDM is, if you want to do a quick calculation, is worth of 80 kilometers of the reach. So if you put 20 ROIDMs on your line,
Mm-hmm.
now you have not 3,000, but maybe 2,000 kilometers distance.
Mm-hmm.
And you have to put this into the simulation. You have to simulate it. And you cannot just go by the marketing paper saying, I have here 3,000 kilometers. It has to do 3,000 kilometers.
Right.
It's much, much more complicated than that. And that's something which people might inadvertently drop into a really problematic situation when they just design the network and then they start building it and oops, it doesn't work.
I'll tell you what, right? Like if people do that, then they'll learn really, really quickly that, it's not to trust blindly, leave some buffer and, the, percentage of error that you want to factor in.
Those nice numbers you see when you look at the specification, especially in the kilometers,
Yeah.
that's a summary of all possible parameters of the transmission.
Mm-hmm.
So your OSNR, like what is the minimal separation of the signal from the noise, what is the chromatic dispersion tolerance, what is the PMD, what is all of these nonlinear effects, all is mixed into that one number.
Yeah.
So instead of just showing you 20 numbers, which nobody really understands what they mean, and you have to spend a lot of time saying, they rather say, okay, this interface can go 80 kilometers.
Right. And which is understandable, right? They do have to summarize, they do have to simplify for people.
Exactly. Like if you want to do a quick decision, you know which one to use, but you have to understand that this is an assumption that you have decent fiber, that you have a decent network. And it's like the reach of electric cars. You have 300 kilometers or 500 kilometers specification from the car manufacturer, but you hit the gas and no, not gas pedal, it's just accelerator. It's not a gas pedal. And you drive 160 kilometers an hour, you will not make 300 kilometers. It's
Yeah.
the same thing is here. You have to be more mindful and you can't just blindly trust stuff any AI tells you.
Sure. No, absolutely. I agree 100%. And I think, we'll see, right? We'll see how things would change. And, but this is where expert like you shines, right? Like you're combining theoretical knowledge with practical experience, operational experience. You couple that with a AI assistant. That is where you start making, presumably better decisions. So, I mean, we're coming up on time here. I wanted to ask you about any call to action on people who listen to this episode. And I know you did mention about, starting with make a list of small stuff to tackle and to see where you can automate next. And is there anything else any call to action besides that point?
Yeah, like they create a list of annoying tasks and start automating. It will take you longer than doing it manually, and that's okay.
Okay.
If you try to automate first time and your task was taking you manually, just copy pasting something in Excel spreadsheet or whatever, takes you a couple of hours. You will spend probably days trying to figure out how to automate it. But it pays off. Over time, you will be saving time on that task. Presumably it is repetitive task, but you will learn something new. So next time you try to automate, it will be much faster. You will be reusing your old code, you will be reusing your old experiences, and you will go faster and faster and faster every time. Just pick small steps. Don't try to do everything in one, and don't try to automate your whole job. You will lose it then.
Or don't try to ask AI and be authoritative, right? Like if you haven't been listening for the last 20 minutes, that's like kind of the conclusion that we arrived to.
And then one day, 3 or 4 years down the line, you will look at some old code and you will say,
Yeah.
who the hell wrote this thing? Is absolutely awful. And then you will hit the blame button and you will see your name next to it.
Your GitHub handle on, yeah.
Yeah. And then you will know you actually making progress, that you are now much, much better software developer and automator than you were 3 years ago. And I had that moment quite a few times, especially when my projects then went to like multiple contributors. So I had the reason to think, okay, somebody wrote something really bad here. This is really, really ugly. And then, it was me. It was me 3 years ago.
No documentation, no comments. You're like, okay, who do I blame? And then it's like, oh, okay, it's Michal of 3 years ago, but you've improved so much that you're leaps and bounds from 3 years ago. So Michal, I really enjoyed our conversation. I think the biggest takeaway that I have really from this conversation is even something you think is not like, I have to raise my hand and put myself in the camp of thinking the transport network, especially fiber optics, are not automatable. But you are the living proof, and you came on the show to disprove my theory, right? Like it's automatable. If the technology have improved, even for complex tests that you still could make a list and you can make progress toward it. So I do thank you very much for coming on the show. Where can people follow you? And if they want to learn more about your work, maybe they want to reach out for consulting gigs, maybe. So where can people find you?
Definitely on LinkedIn. So you can find me under my name, Michal Pecek, Pecek, on LinkedIn. And I also teach the optical communication for OTT, so optical technology training.
Is that for a particular vendor, or what platform is that on, or you just teach it by yourself?
It's OTT.training. It's a vendor agnostic training. It's really the theory behind the optical transmission. That's the main thing, that we do not teach how to configure a network with a specific vendor.
Hmm.
We teach people to understand what is behind, what is actually happening in the network. And then you can do and work with specific vendor on the specifics of the equipment, but the theoretical background you can get with us.
Nice. I remember I had some optical training back in the days, and it was really helpful. It was eye opening for me. So we'll definitely put that in the show notes. And thanks again for being here, Michal.
Thank you very much for having me. Bye-bye.
Thank you for listening to this episode of Network Automation Nerds. Do you have any feedbacks for Network Automation, our guest Michal today, or this episode? Please do send us some follow-ups at packetpushers.net/follow-up. We do want to hear from you. And please check out our website at packetpushers.net to find other network engineer focused podcasts, blogs, YouTube videos, sign up for the newsletter, and so much more. You can find podcasts such as Network Break, Heavy Networking, Packet Protector, Total Network Operations, Day 2 DevOps, and so much more. And we do thank you, the wonderful listeners, for your support. Last but not least, remember that too much network automation will never be enough.